Hey friends, welcome to follow up. Let's have a look at problem 859, body strings. This is today's daily challenge problem, which is marked easy by leetcode. Actually, for this problem, indeed, it's very straightforward. However, in this video, we want to demonstrate that we need to treat edge cases for this specific problem. So with that said, let's first look at the problem statement. So we are given two strings, S and go. So we want to return true if we can swap two letters in S so that the result is equal to go. Otherwise, we return false, right? So here, swapping letters is defined as taking two indices, I and J, right, such that they are not the same, and we swapping the characters at the two positions. So here is an example, right? So if we swap the 0 index character and the index 2 character, so we have C, B, A, D, right? So here we have several examples, right? So in the first example, we have AB and BA. So if we switch A and B in S, so we get go. So in a reverse direction or relative direction, you can think of swapping the two letters in the go, right? You also get S. That's why we return true in this first example. So in the second example, the two strings are the same. We need to return false. The reason is that all the characters here appears just once, right? They are unique. And then if you switch, if we do once such operation, so they are no longer the same. So in the third example, so it's actually a different case from second example. So in this one, so S and go are also identical. However, the letter A appears twice. So we can, for example, switch these two letters at index 0 and index 1. As they're the same, so you switch or not. So essentially they're the same. So again, after switch, they are equal, right? So that's the difference of this one with example 2. Secondly, not secondly. So let's look at the constraint. So here the length and of S and the length of go is in between 1 and 2 times 10 to the power 4. So this number 2 times 10 to the power 4 is a decent large one. However, from this assumption, we don't know if S and go have the same length. So this is also an edge case we need to treat ahead of time. So secondly, S and go consist of lowercase English letters, right? So because there are only 26 lowercase English letters, if the length is longer than 26, it must have 9 unique characters. In other words, some letters appear multiple times. So with that said, let's look at a solution. So here, basically, overall, we want to check for S and go, how many positions or how many at which indices they are corresponding to different characters. So for this, I'm going to directly do the coding, and in between, we're going to make the logic clear. So you can also think of this as the process of translating the thought process into coding. The first thing first, that is to check the edge case. That is, if length S does not equal to length of go. So in this case, no matter how you swap, so they are not. It's impossible for these two strings to be the same. So we are going to return false, right? So after this check, then actually S and go would have the same length, right? So we want to check the net places where they're different. So here, n differences is the indices, the number of indices where S and go are different. So also I'm going to use the find this ID. So because we want to do a swap later, and then we're going to do the check. So basically for I, character A, character B. So this is just two variables, right? In enumerate. So here I'm using enumerate because I need to track the indices. And then I'm going to use zip S and go, right? So for traversal. And then if A does not equal to B, right? So then the number of difference in diff is incremented by 1, and also the IDS is appended by this ci, right? So this way, after this traversal, we're going to have the number of places where the two strings are different, and the IDS corresponding to those positions, right? And then first we want to check if the difference is not 0 or 2, right? So we want to have 0 like this. We need to check again, right? If we have more than 2 positions, they are different, so it's impossible to make them equal by a swap. So let's see, we can use a set actually. So 0 or 2. So if this is not true, so we're going to return false, right? So another case that is ndef equals 0. So in this case, this is very special, right? So we treated the case that is ndef not 0 or 2. Then we need to treat the case when a def is 0 or 2, right? So in this case, if they are the same, in other words, they are the same character, we need to know if S or Go contains non-unique characters. In other words, we need to check if the length of S is greater than 26, right? Oh, that's just not sufficient. So we for safety. So if in other words, if S has a length larger than 26, it must have non-unique characters. But in general, if we do not have a smaller length, still it's possible to have non-unique characters, like in example 3, right? So let's use the hard way. So let's get collections. Let's get the counter object. So string. So you can use Go the same. So we want to see if max of D values is greater than 1, right? So if it's greater than 1, so we're going to return true. So this corresponding to example 3. So if it's just 1, so we're going to return corresponding to this one, return false. So this is the first case, ndef equals 0. Otherwise, ndef equals 2. So for IDX, it must have length 2. Right? So let's get the two indices, ij equals IDS. Then we can swap the corresponding position and make a comparison. So in other words, we want to return if si equals go at index j and sj equals go at index I. Due to the way we do the for loop, so these two indices must be different, right? So if we can do swap and make them the same, we just need to make sure our swaps, these two positions are the same. So this forms a full solution format for this problem. So now let's do a test first. So invalid, invalid if not in, right? So let's check again. Yeah, it does the job for ABBA. This is the first example. Now let's look at the second example, AB. So we need to return false. Okay, so now let's look at AA. So we need to return true. Right. So now let's look at the generic case. Yeah, it passes all the generic cases. So here actually we provide one format of solutions to this problem to just explain the main idea. So as the problem is easy one, and you can modify the code, shorten the code, and write other solution format. With that said, that's basically about it for this video. Thank you.